Hi everyone, this is a second video looking at performing calculations for Pythagoras' theorem when we find right angled triangles in circles. Question here for your starter is based on the stuff that we have done last lesson, so please complete this and then come back on for the answers. Okay, so the first thing to notice here is that we have a right angle at angle Y. We are trying to find the length xy, which is that length down there. Our 5 metres for the diameter, we can label that as C. That has to be our longest side. A and B are the other two sides. So in this case, I'm trying to find side B. We're always using the same formula for Pythagoras' theorem. We then can just rearrange this if we have to find one of the smaller sides. So 5 squared equals 2.5 squared plus b squared. Take away 2.5 squared from the 5. So 5 squared take 2.5 squared. That is equal to b squared. So b squared then, if we just swap around the sides, 2.5 squared. That calculation can go straight into the calculator. Again, if you're using your phone, probably best to square the numbers first and then subtract them. That gives us then 18.75. The last step is to square root the 18.75 to get our final answer. So 4.3 metres is the final answer for the length of xy. Now, additionally to kind of looking at right angles inside circles, like we've been looking at the past week, we can also find right angled triangles inside, like directly inside the circle on different parts of the circle. So we can use this diagram here and the explanation at the side to introduce this skill. So we have a chord down the bottom there of the circle, which I've highlighted in red. Now this chord directly halves, the radius directly halves that chord along the bottom. So the radius is the one from the centre of the circle to the outside. It just hasn't been extended past the chord, but if we were to draw that through, it would directly half the chord, which is why there's the two lines on either side. In addition to that, we know that another radius is along those both diagonal lines as well. And we can use all of these different facts when we know some of the lengths of these sides to be able to use Pythagoras' theorem and calculate various missing lengths. So, this question here, we are asked to find the length of EB. Now, EB is that line here. In this particular question, we are not given a right angled triangle that contains the length EB. However, what we are given is a triangle which contains the length OE, ED, and OD. That's a right angled triangle. As you can see, the radius of this circle is 10 centimetres, meaning the full length from O to B has to be 10 centimetres. So for this particular type of question, if I find the length of OE, so the red horizontal line in the right angled triangle, I can then subtract that from the 10 to find out the length of the blue section. So it's the blue section and the red section make up the radius, so that's the whole 10. I can do the 10 take away the section that I find from the triangle. So the triangle then looks like this. I'm just drawing it outside of the diagram just so that I can see exactly what numbers to use. So using Pythagoras' theorem then, C is over there, A and B will be the other two sides. C squared equals A squared plus B squared. There's no need to do this step very slowly. That's 8 squared. So a squared has to be 10 squared, take away 8 squared. Okay, missed out a couple of lines in there because we have looked at these calculations a lot yesterday. A squared is 36, so a is the square root of 36, which is 6. Now that tells me that the length here from O to E is 6. So the length EB, which is the line that I've still marked in with the blue, is the radius, which is 10, take away the 6 that I've just calculated. So the whole length down here is the radius. It goes from the centre of the circle to the circumference. Therefore, it has to be 10. I've chopped off a little bit of 6 at the top. So EB is 4 centimetres. Okay. The units of length in the question are centimetres. So that's the ones that we have in our answer as well. The next example. This is how you will see a lot of the examples in the worksheet again. So a bit of explanation at the left-hand side and a diagram on the right. So for these, I would probably tell you to copy the diagrams, and that way you can then decide which sections you're given numbers for, and so on. You can mark them on. So for this question, we're told the radius is 13. So that's that bit there, the black line. But it is also the line OB. Okay, we'll have to come back to that in a second. What I'm given in the circle is a right angled triangle, OKN. I am told that the chord MN is 24. So the whole length of the chord, the red line, is 24 centimetres. Therefore, the bit at the edge, KN, has to be 12 centimetres. So again, I'll draw out this little triangle, and you'll see that this question is actually the same, or at least very similar to the question we did in example 1. So C, A and B of the triangle, C squared equals A squared plus B squared. 13 squared is A squared plus 12 squared. So A squared is 13 squared, take away 12 squared. Given 25, therefore A is the square root of 25, so A has to be 5. Now, this is example A, question A, which actually tells me that that line OK is equal to 5 centimetres. Now, the line KB is that line there. From the last example, we remember that OB is a radius of the circle, which is 13. So this bit here, OK, is 5. So 13, take away 5, and we will get 8 centimetres. So KB in this question is 8 centimetres. When you see your questions later on, that's what I want you to consider. I want you to have a look at what lines is it actually looking for you to calculate. Once you want to find that line, have a look and see whether it's attached to a right angled triangle. In most cases it will be, and with a lot of these questions they give you parts A and parts B to try and lead you to the final answer. So they won't just ask you to find side KB, they'll ask you to first find a side that's attached to the triangle and then use that to find the missing side that they really want you to find. On to our last example. So this is from a Nat 5 past paper, and it still involves Pythagoras and circles. We're just not given as much information on the diagram. So the first thing I'm reading from this piece of information on the right hand side is that the radius of the circle is 1.2 metres. Now on this circle I need to create a right angled triangle in order to use Pythagoras' theorem. I want to use this chord as that's one of the pieces of information that I'm given. So therefore, I am going to take the radius from the centre of the circle to one of the edges. It doesn't matter which side you take this to. I'm taking it to the L. If you took it to the M, it would be the same calculations. Now, additionally to that then, I am also going to need to create the triangle, and the triangle, more often than not, comes from the centre of the circle. The reason that I've put in that line there, going up the way, is because then I know that M and L are the same size. Okay, so for the next piece of information, ML, the full chord, is 1.8 metres. Therefore, one side of the chord has to be half of that, which is 0.9, since the two sides have to be the same size. Now, if I mark on the radius length as well, that's 1.2 metres. I am looking to calculate the depth of milk. Now, that is in fact this line, the smaller line within the triangle, added on to that line there. So it's the full blue line. As you can see, it's on the outside of the shape as well. That means I'm going to have to find the smaller line inside the triangle. Okay, so that will be that line over there with the right angle here. And then I've got to add to that a radius. That's the inside of the circle to the circumference. Therefore, that 1.2 applies also to the line on the bottom. So this triangle had the numbers 1.2 and 0.9. C was 1.2. I'll say B is 0.9 and A is the one that's missing. So C squared equals A squared plus B squared. 1.2 squared equals A squared plus 0.9 squared. Let's rearrange that. So we've got to take away 0.9 squared from the 1.2 squared. And we're left with 0.63. Now, again, A is then the square root of 0.63. So A, or the smaller part of that triangle there, is square root 0.63. Gives me we'll take it to one decimal place, so 0.8 metres to one decimal place. Now that tells me that 0.8 is in here. Therefore, the whole depth of milk within the tank is the 0.8, which comes from the top of the milk to the centre of the circle, and then the 1.2, which comes from the centre of the circle to the bottom of the tank. 0.8 and 1.2 is equal to 2 metres in total, and that's our final answer. Okay. You will see a question similar to this in the worksheet. Most of them will be of this sort. I've taken this from question 1 in the worksheet. So it's questions like this that will lead you to find this little section and then apply what you've just done to calculate another missing section that maybe requires a bit more thought. Please, as you're doing these questions, stay in touch with me, ask for help if you need to. And you can rejoin as well the live call if you're on the Teams page during the lesson to ask for help if you need to. Okay?